Everyone, tutuloy natin yung lecture natin. So, we have recently finished yung application ng load combination by using yung edit or paggamit ng load combination. So, gumawa tayo ng rules natin ng auto load combination and then yun yung in-apply natin sa structure natin. Also, nagdagdag na rin ako dito previously ng perform analysis. So, meron na tayong perform analysis dito because if kailangan kasi natin i-run muna yung structure o yung calculation because i-check natin yung static force procedure na ginawa ng software para dun sa seismic pagkuha ng base shear. So, ito yung calculation niya. Kakailanganin natin to mamaya. Yan. Now, para sa lecture na to, what we're going to do is pag-usapan natin yung konsepto ng drift and then titignan natin or we are going to look at how do we utilize the software to obtain yung mga gusto nating information na result ng analysis. Unahin muna natin yung drift which is related sa seismic. This can be found under 208.6.4, so drift. Alright. So, under, nilipat ko sa Word. So, tignan natin dito. So, nilipat ko yung content. So, basically, ang tinutukoy lang dito is, ito yung gagamitin natin for drift check pertaining to yung, particularly, yung gagamitin nating load combination is 203.3 which corresponds to LRFD load combinations. So nagawa na natin to. I mean, meron na tayo nito. All we need to do is utilize it in our inputs. So again, kinopya ko na to sa Word. So basahin lang natin. May naka-indicate dito na exemptions. Ito pala, kasama to. Yan. Continuation niya yung number 2. So, yung exemption number 1, I'm not going to read it as word by word. No? So, ang ibig sabihin lang naman nito is, pwede nating ignore yung drift limits if alam natin na kayang isustain ng structure yung lateral deflection ng overall na structure natin. So, hindi affected yung structural element as well as yung non-structural element ng ganun kalala. Or I mean is, kayang i-tolerate. So, yung term na ginamit kasi dito, i-tolerate. So, kayang i-tolerate ng structural elements natin and non-structural elements in terms of yung life safety level ng checking. Okay, so kapag ganun yung case, alam natin na okay lang naman, hindi ganun ka-affected yung structure, pwede nating i-ignore daw. Or we can also use yung number 2, sabi niya dito, there shall be no drift limit in single-story steel frame structure. So single technically, parang pwede nating ignore para yung sa sample natin kasi it falls under yung category number 2, no? But for the sake of yung yung example lang, i-force pa rin natin, no? Hindi naman sinabi dito na bawal gamitin yung drift check. We can still check also kasi yung height ng ating structure medyo mataas din, 5 meters. Okay, and then ito yung provision ng drift check. Ito daw yung maximum elastic response displacement, delta M. Inelastic response displacement, delta M. Ito yung formula. So, 0.7 ng R and then delta S. So, yung delta S is static deformation. Most likely lateral to. Yan. Yung R is yung ginamit natin na R value dun sa seismic calculation. So, simplified static procedure. And then, may limitation. Sabi niya, yung calculated value daw ng drift delta M shall not exceed. So, it should be less than 0.025 ng height ng structure kapag yung t-value natin is less than 0.7. But we are going to use less than 0.02 ng height ng structure if the fundamental period is greater than 0.7. Greater than or equal. Okay, so greater than. Sana yon? For the structure having a fundamental period of 0.7 or greater. So these two will go hand in hand. So simultaneous silang gagamitin to make sure na yung structure natin is within the limitation of drift checking. So yung total height ng structure natin until dun sa roof niya is nasa 5 meters, no? 4 yung height ng column, and then yung roof natin is nasa 1 meter. Now, i-separate natin yung X and Z. Now, kinopya ko na dito yung information ng ating R value. I mean, yung input natin dun sa graph lang natin, no? Yung input natin dun sa R value. So, para dun sa X, ang ginamit natin is 8. In-assume natin na moment frame na special. While dun sa X, or should I say yung sa Z, yung assumption natin dito is intermediate lang. Yan, 4.5. So, gamit yung formula na to, no? So, palitan lang natin yung mga naka-indicate dito na subscript. Dapat this one is Z. Alright. So, ito yung formula, 0.7R delta S. Yung R natin is 8 for yung X direction. And then, ito yung limitation ng delta M, no? So, una is kukunin muna natin yung period, fundamental period. So, you can pre-calculate this or gamitin mo yung Staad para gawin yung calculation. What I mean is, nag-run tayo ng analysis. Meron tayong result. So, ang gagawin natin, punta tayo sa utilities and then outputs. Kasi meron na tayong output. Kapag naka-gray yan, ibig sabihin wala pa tayong perform analysis. So, we click this button right here and then we must look for the calculation, yung static force procedure na ginawa ng software, which is andito. So, ito yung para sa X direction. Then, ito yung para sa Z. So, ito yung kinopya ko na fundament na period value. T for X is 0.113 and then for Z is 0.054. Yan. It is less than close ko lang to. Less than nung limit, so ito yung gagamitin natin, 0.025H. Now, meron tayong option dito to use yung delta S mismo, yung actual value niya. So, kapag hindi ka gumagamit ng software, no, I mean, you're using different software. Kasi may ibang software na ang gamit is yung value mismo. So, automatic na value yung gagamitin as limit. Meron din naman na yung mga inputs katulad ng Staad is kailangan na naka in terms of height. Naka in terms of height yung factor niya. So, depende sa software na gagamitin natin, but in our case, ito yung gagamitin natin kasi Staad yung gamit natin. Right. So, ang case ngayon dito is kukunin natin yung delta M, no? So, yung delta M gamit yung formula na to is 0.025 times 5. Equate natin yung value ng M na to dun sa original na MX natin dito sa taas. So 0.7 times 8 times delta S is equivalent to yung value ng delta M dito. Let's just eliminate yung less than. No? So pwede nating sabihin na equal. So yung delta S natin dito will be 0.0223 meters. Or like I said, kapag in terms of H, wag natin isa-substitute yung value ng H dito. So, papalitan natin to ng H lang. And yung ating delta S would look like this. What we want is yung factor dito. Ito yung kailangan natin. May change its color to something that is recognizable like green. That is for yung X. We will do the same for yung Z. May R value tayo, TZ, and then yung kanyang final value ng kanyang delta S in terms of H is 0.007. So, ito yung gagamitin natin for yung drift check natin. So, what I'll do is magde-define tayo ng command. Or, it's not really a command. So, pre-analysis command tayo. So, pre-analysis command tayo para ma-establish natin yung gagamitin natin na load combination for yung check. Kailangan kasi nating sabihin sa software na hindi lahat ng load combination dito gagamitin. I mean, load cases. May particular dyan na load cases para doon sa X and then para doon sa Z. So, let's tell the software to do so. So, pre-analysis command and then define command. Sorry. Diretso tayo dito pala sa load list dito. Naka-isolate na pala siya. So, load list tayo. Okay. Maglo-load list tayo. So, unfortunately, hindi masyadong makita kasi maliit. Anyway, ang gagamitin natin dito will be yung mga load combination. So, ang load combination para dun sa 203.3 na nanggaling sa, ay para dun sa LRFD will be 7 until 20. Gamitin lang natin yung mga critical kasi most likely anyway, gawin natin yung calculation. So, balik ako dun sa aking loading para ma-establish natin kung ano ba dapat yung gagamitin dito. Ano yung para sa X and ano yung para sa Z. So, anong load combination? Let's start with yung X direction. Although hindi naman to necessary, you can just mix them together. Pero, just for the sake of having a separate command for yung X and Z, ito yung gagawin ko. So, X, I'll include number 7. So, ano pa ba? Number 8, number 9. 8 and then 9. And then, although dapat seismic lang sana, pero anyway, dagdag na rin natin lahat, no? Along the X, that would be wind number 1, which is load case number 5. That would be number 10. 10. And then number 12. Okay. Number 14. And then 16, 18. Alright, 16, 18. Okay, so sa Z naman, that would be 7 to 8, 7 to 9 pa rin. And then ito is magiging 11, 13. Alright, 13, 15, 17, and then 19. Ito yung para sa X and then para sa Z. So let's do the checking this time. So babalik ako sa analysis and then load list muna tayo. Right. Seven, 8, 9, 10. Ay, 7, 8, 9, 10 para sa X. 12, 14, 16, 18. Right. That is for yung X. So, or, okay, may mali akong ginawa. Hindi ako ay, okay lang pala. So, ito yung load list natin after nung perform analysis. So, load list. Right? And then, next is, maglalagay tayo ng, ayan. So, yung load list is under post analysis command. Analysis command ulit tayo, and then, alright, so tapos na yung load list natin. Next is dun sa post analysis command tayo. Yan. And then i-define natin yung checking natin. So it's available under story drift dito. Okay. So we have already performed yung load listing natin. So okay na siya. Nandito na. So, story drift, ang gagamitin natin is yung story drift para doon sa X direction. So, ano ba yung value niya? Ito. Story drift. And then, add. Alright. Well, that's it. For yung X. Subukan muna nating i-run for the sake of yung baka may mga mali tayong nilagay na input. Yan. So, ito yung story drift natin. Ano yung result niya? Mukhang pass naman lahat. Obviously, kasi one story lang naman. Maliit lang. Tapos, hindi ganun ka laki yung mga loading natin. So, yung, as well as yung sa Sysmic kasi medyo magaan din kasi wala masyadong kinikerry na hindi ganun kalaki yung weight niya. So, most likely, yung ating distributed na, vertically distributed na mga storage here is maliit lang. Kaya, maliit din yung result natin dito. So, within limits pa rin naman. So, pass lahat. That is for yung X direction. Subukan natin dun sa Z naman. So, we'll have to add asan ba yung command na yun? Okay, i-manual na lang natin. So, we can just go under utilities and then command file. We tell the software to do some changes. No? So, i-change natin. And then, we might as well do yung checking dito na rin. No? So, I'll just copy. Para dun sa Z. So, ito yung para sa X, ito yung para sa Z direction. So, 0 to 9, tapos 11, 13, 15, 17, 19. And then, yung limit natin na na-solve natin is ito. Right. Let me just save the changes. Close natin yan. And then, mag-run tayo ng analysis ulit. Alright, so ito yung para sa Z. And nothing's wrong with yung ating structure. So far, okay naman. Now, paano kapag may failure? Kapag may failure, it means that hindi adequate yung section natin to resist yung or yung framing natin in total. Yung framing natin in total, hindi kayang i-sustain yung hindi niya kayang ano ba yung term na ginamit doon? It cannot tolerate yung lateral drift. So, ang gagawin natin is we will have to modify yung structure. So, it's either we increase the stiffness of yung overall na frame natin by increasing yung stiffness ng mga lateral resisting elements natin katulad ng column as well as yung mga beams, or pwede tayo magdagdag ng mga diaphragms, mga bracings, shear walls para i-resist yung lateral force. Pwede natin palitan yung configuration ng structure, magdagdag ng mga columns or what. That is to eliminate yung effect ng drift. So anyway, we have already performed yung analysis. Pupunta tayo dun sa paraan ng kung saan pwede nating ma-visualize yung result ng ating analysis. So dun sa post-processing, andito lahat yung result ng analysis natin. So for displacement, reaction of forces, reactions of forces. Reactions, saan ba yun? So, pwede natin tong yan. So, yung mga reaction ng supports natin, beam results, wala tayong plate, wala din tayong solids. We can generate yung report by setting up yung information na kailangan natin. But anyway, sa displacement, pwede nating i-visualize yung magiging deflection ng structure natin. Depende sa kung ano yung ginagamit natin na load case. So dito, meron tayo nung load cases. Actually, dapat balik muna tayo dito. Alright, apply. Ayan, sa combination pala, no? So, pwede nating itagal yung mga combinations dito para makita natin yung deflection effect nila. Now, medyo exaggerated yung result, no? So, paano natin ayusin para makita natin na mas maigi? You can press Control on your keyboard and then scroll yung mouse up or down. Ayan. Okay. Or, pwede rin naman na punta tayo dun sa may view and then dun sa may label settings under scale right here and then displacement, pwede nating baguhin yung yung displacement dito. So let's say mag-trial and error tayo ng napakaliit. Apply. A little bit and then masyadong malaki. Still, ganun pa rin, no? I'm not sure if yung problem dito is yung UI or anyway, pili tayo ng ibang load case kasi parang yan, this one. Ay, hindi. Okay. Yung sobrang laking displacement dito is actually yung ating dummy member kasi masyadong manipis. Kaya ito yung nagbibigay ng kakaibang result. So, pwede nating i-isolate yan. Let me just select my whole structure. Along the right side siguro. Saka natin tanggalin yung mga dummy. Again, yung dummy natin dito is for the sake of demonstration lang. And then gawa tayo ng ibang view. So, manage, add view. Hindi. At new na lang, new view. Create a new view, okay. And then isi-save natin to as except dummy. Yeah. Okay. So, open natin yung except dummy. Dito natin ilagay. Ayan. So, para hindi makita yung dummy nodes. So, dito, pwede nating palakihin yung deflection by using yung mouse natin. Scroll, control, i-press natin yung control sa keyboard and then up and down lang yung mouse wheel. Scroll lang natin siya until may makita tayong visual na change dun sa display. Kapag ayaw pa rin, ayan, meron na. So, ano ba yung scale nito? Yung scale nito is scale displacement 0.2. Ayan, so 0.2. Before you proceed with yung further na inputs ng mga data, before kayo mag-proceed sa design, kailangan muna nating inspect kung reasonable ba yung deflection or yung mga result ng ating analysis. So what I mean to say is, kung titignan kasi natin dito, ano ba to? Dead load and then seismic along the Z direction. So mukhang tama naman kasi yung direction ng seismic natin papunta rito. So yung deflection natin lateral, tama yung kanyang direction. So subukan natin yung iba. This is dead load only. So dapat wala tayo masyadong lateral deflection, although like I said, hindi siya assured na wala tayong lateral. So meron pa rin. Ang laki ng effect nung ayan. So ito yung dito natin makikita yung impact doon sa configuration ng structure natin. Bakit kanyo? Kasi remember na ang ginawa natin dito, ginawa natin tong linagyan natin to ng beta angle. So yung stronger axis natin naka-orient on the other direction as compared sa mga ibang mga members. So unfortunately, hindi pala maganda dito sa setting natin. Yan. Kitang-kita naman dito because dito pa lang meron na tayong relatively small na irregularity doon sa structure. Maliit na irregularity. Yung deflection natin hindi na uniform. And then we can just view all of yung mga loads natin. Ayan, ito is dead load and plus ano ba to? Plus wind along the X. So mukhang tama naman. Mukhang mas malaki yung impact ng wind versus kay seismic. Ayan. So dito natin ma-observe na yung impact is mas malaki yung wind effect. So yung X yung seismic ganyan lang kaliit. While yung wind ganyan. Laki yung discrepancy nila. What else? You can play with yung animation. So pwede kang mag-animation. So deflection, apply, okay. And you can animate your structure to better visualize yung result. Ayan. After nyan, you can also check yung result ng support reactions natin. So, by the way, I forgot to mention, andito yung summary. I mean, yung overall deflection ng joint number 1. Joint number 1 with all of yung mga provided na mga load combinations. Alright? So, if it is being required na ilagay natin to sa report natin, then ito yung kukunin natin. Deflections. Meron din naman yung summary pero masyadong summarized to. So, overall, Ito yung overall deflections. Ito yung mga pag-clinic natin overall, yung summary. Dito sa may cell na ito, ayaw niya. Ayan, double click lang. Or, come on. Ayan. Ang mangyayari ngayon is masaselect yung mga member na merong maximum and minimum dito. Right? So, automatically, ma-identify natin kung alin ba sa kanila yung bibigyan natin ng attention. And anyway, so that's it for yung displacement. Meron din tayong relative value. And then, sa support reactions naman, andito siya. So again, katulad dun sa may displacement, meron tayo ng summary and then meron tayo ng envelope. So additional na option ay na option na report. Okay? So if you want to include this one as your report, so pwede mong i-copyahin to sa spreadsheet. Copy and paste lang. You can copy the entire data and then i-paste mo sa spreadsheet. Pwede. Yan. And then printable na siya. So, if you do not want to use yung reporting system ng Staad, then pwede mong gawin yun. Okay, ito yung mga value visually, no? So, medyo overlapping sila. So, pwede nating i-isolate sila by using select, text. Pwede nating ilipat-lipat yung mga box na to. Yan. So, kung gusto mong i-present na ganito yung presentation mo ng support reaction, then okay lang. Kung mapapansin natin, since naka-pin support tayo, free yung MX, Y, and Z. Right? What else? Beam results. So, yung beam results natin, like deflection, FY, FX, ay yung mga moment and shear diagrams natin andito. Yan, for different load combinations dito. Right? And with that, just like yung ginawa natin dun sa reaction and displacement, pwede rin natin itong copyhin lahat. Okay? If it is necessary, if it is required. But if hindi naman required, then you can perform other techniques para ma-reduce yung size ng information na kailangan. So, ano pa ba? Beam stresses kung gusto mong tignan or ano ba yung sinasabi ko? Kung gusto mong tignan yung impact dun sa structure natin, so meron tayong iba't ibang other datas dito katulad ng ito hindi pa accessible to. Gagamitin natin to mamaya. May beam forces, beam stresses dito. So subukan natin. Stresses. Yan. So pag nag-click tayo ng beam, yan, i-display niya yung stress distribution based dun sa gradient from lowest to highest value. So, if you want to, perform parang finite element analysis na, gusto mo na may finite element result na hindi ka magpo-perform, parang ito yung pinakamabilis na paraan. Yan. So, you can visualize yung stress dun sa structure or sa element mismo visually. You can visualize tapos visually. You can visualize yung result ng analysis. So, yan. Okay, I'm not going to to stay too long on yung part na to kasi hindi naman natin masyadong gagamitin muna. No? So, ang goal talaga natin is i-design yung structure. So, let's just assume na wala tayong naging problem dun sa analysis. Everything is working as expected. And then, isa pa pala, no? Additional na information. You can double-click dun sa element. Lalabas yung additional na mga analysis information. So, shear bending, and then yung mga deflection. Kung gusto mo ng individual na results. Alright? And I guess yun lamang for yung portion ng lecture natin na to.